One of the most useful tools a programmer has is using variables. Now, every variable has a specific type, and in Java, the simplest variables are what we call primitive types. These types are not objects. Java is an object-oriented programming language, so you've probably heard that term. But primitive types are not objects. We'll actually use primitive types in our objects a lot of times, but they're separate. A primitive type just holds a value. That's it. So once you declare that memory, there's some memory location that stores that particular value. Now, we're not going to get into how those values are represented and so forth. That's a different conversation. But the main takeaway here is that a primitive type is just a value. So Java defines 8 primitive types that we're able to use. There's 4 integer types, meaning the integers, 0, 1, 2, 3, 4, negative 1, 2, 3, 4, and so on. The reason there's 4 different types is because each one is a different size. So the more memory a variable uses, the more values it can represent. There's also 2 floating point number primitive types. Again, they're differentiated by the size, and the size tells you how large, or in the case of floating point numbers, also how precise that number can be. There's a character type that's going to hold characters for us. And then finally, there's a boolean type that'll hold true, false values. So let's take a look at how we declare these types of variables. We'll also talk a little bit more about their sizes. So here we have an empty class, and we'll declare some primitive variables here. So the most common primitive type is usually going to be an integer type. So let's declare an int, and we will call it num. A very not interesting name, but that'll work for us. And an int is a 32-bit integer. Now 32 bits means we have 32 binary digits, zeros and ones, to represent this number. One of those is going to represent the sign, whether it's positive or negative. So essentially we have from negative 2 to the 31st power to positive 2 to the 31st power minus 1. That would be the range for those values. So you have a lot of values that would work there. And we'll use a double for numbers with a decimal, our real numbers. And that's going to be a 64-bit floating point number. Floating point numbers are a little more complicated to represent than integer values. And I also mistyped that. One thing to keep in mind, though, is that floating point numbers are not going to be exact. So if you do something where you're taking 2 floating point numbers, let's say 32.0 divided by 16.0, there may be a little bit of error, and so you won't necessarily get the integer 2 as the result. And so just something to keep in mind. The error is going to be pretty small, but as you use more and more floating point numbers in the calculation, that error does grow. Something to keep in mind when converting between doubles and integers. Our boolean type is going to hold a value of true or false. And our character type, char, is a 16-bit Unicode character. Now it's typically going to be represented under the hood by an integer. That integer represents some specific Unicode character. Each one of those has its own integer value that can be stored there. Now we skipped a few that aren't quite as commonly used. So the first would be the byte. So that is an 8-bit integer. A short is a 16-bit integer. And a long is a 64-bit integer. And you'll notice we have 4 different kinds of integers: int, byte, short, and long, each of which has a different size. That size tells us what our maximum value would be, or our minimum negative value. We want to make sure we choose an integer type that's sufficient for our purposes. Now, there's no reason to have a bunch of longs because you're wasting memory if you're only going to deal with, say, a value that's going to hold a day of the month, or even a day of the year. There's 365 days of a year, so a byte is more than sufficient in that case. And then there's also a float, and that is a 32-bit floating point number. However, since that's not going to be as precise as a double, in general, you want to avoid using floats in any scenario. So these are declarations of variables of the primitive types in Java. Now you will notice that I'm getting a warning on these because I haven't used them yet. So of course I would want to be using these in my code later, but the point of this is just to show you how to actually do the declaration. We'll see later how to initialize these values and how to use them as part of expressions.